Good afternoon. Myself, Dr. R.V.S. Bhadauria from IIMT College of Engineering. Today, we will discuss about three-dimensional printing. So, 3D printing is where user apply a computer for models, object, and the printer made those objects by using that model. This is the modeling, and you can see in this slide the timeline of 3D printing revolution. Another name is additive manufacturing approach. Actually, this is applied in additive manufacturing approach. Now, in this process, a printer creates physical object typically by laying down many thin layer or many thin material layers in succession. Like iterative method, and the process created three-dimensional object in the real world, computer generated image or models. Almost anything can be made out of 3D print, from small utensils to big pieces of machinery. Now, we will discuss about, you can see this slide, the various materials either in the form of liquid or powder are used in this technology. The most common materials are the plastic is used to make small toys, part of things and tools. Metals, these are used in ready to install part like nuts and bolts, and it's also used in creating, designing prototype or different machines. Different type of showpiece and kitchen utensils like cup, glasses, spoons, knives are made of ceramic, and it is also used in designing showpieces. Graphite or graphene. We all are electronic and electrical engineers. For electronics and electrical engineers, carbon fiber and graphite are very important because the graphite used in electronics, lighting, LED, and carbon fiber used in bearing parts of electrical cable installation, etc. CAD, computer aided design. The first step in the additive manufacturing process is produced a digital model for the purpose computer aided design molding is used. This is our fourth slide. In this step, the user designs the design of the object in software for printing it later on. There are many software available that work on CAD, like SolidWorks, Autodesk Function 360, or SketchUp. Now we will discuss about stereolithography. The abbreviation of stereolithography is STL. The modeling in STL formats. In this step of AM, not a amplitude modulation. This is additive manufacturing process, or CAD models is convert a STL file that is acceptable by AM machines. It is also possible to select a STL model from online repositories like Pinshape, GrabCAD, etc. Some of these Thus, brokers offer models for free, some are charged. Now you can this slide. Okay, there are many software STL models manipulations. For example, MeshLab, 3D Print Cloud, NetFab, etc. If there are no error, then some object correction like sizing, density, geometry change could be made. A proper orientation of the 3D models also could be set up. Once a STL file has been generated, it is imported into a slicer program which convert it into GNode. GNode is a numerical control NC programming language used in a computer aided manufacturing CAM to control automated machine like 3D printers. Fourth step is setting up device. Setting up device. In this step, device should be prepared for printing, control, cleaning from previous build and loading print material. When hardware is ready, build file could be uploaded to the machine. And the midway, the routine check of all critical build setting process control is also necessary. The fifth step is, of course, printing. Whole printing procedure is mainly automatic depending on the size of things, machines, and materials employed. There is a need to check occasionally if there are no errors. The procedure might take several hours or even month, days also. Sixth one is removal of prints. Why removal of prints? Because residues or remaining part which we want remove from this printing. In most cases of non-industrial 3D printing, removal of the finished part is simple task, separating the printed part from the print bed. Now you can see look-alike model or actual 3D printer, how it looked. Please take some seconds. This is the printers. This is not a model. This is actual 3D printer. Look like this. History. Some short history of 3D printing. This is very critical part of this printing technology. The Chuck Hall. The first 3D printing device was invented by Chuck Hall in 1983 and based on was known as stereolithography. The process he used is the stereolithography, which abbreviation is SL. In a patent, he defined SL as a method and approach for making solid object by successive printing thin layer of the UV curable material, one of top of the other. Hence, with this invention, he also gave a concept about additive manufacturing. And we discussed before the process of creating an object by building it one layer at a time. This is called additive manufacturing. This is the SLS printer. SLS printer is very revolutionary. You can see in this slide, the two brothers of Texas in 1986, SLS printer was developed. SLS is laser sintering. patented by Dr. Carl Decker and Dr. Joe Berman. These two scientists patented this new technology, new technology at that time. You can see the figure, you can see this picture, the two scientists. Left one is Dr. Charles and right one is Joe Berman. And in 1989, S. Scott Crump, with his wife and Stratasys co-founder Liss Crump, the field of patent fused deposition modeling. This is a new name, new technology, SL, STL. Now this one is FDM, fused deposition modeling. FDM is not here. This is not a frequency division multiplexing. This is the fused deposition modeling, and trademarked by the Stratasys. As such, many industry professionals used another name, fused filament fabrication. Actually, FDM and FFF is same technology, but patented by another name. Some industry used another name, FFF. By 2005, additive technology patents were starting to expire. In 2004, RAPRA project was launched at the University of Bath by a senior lecturer and mechanical engineer, Dr. Adrian Boyer. The project aim was to create a low-cost 3D printer capable of replacing itself. And on the 9th February 2008, RAPRAP 1.1, Darwin successfully 3D printed over 18% of its own components. This is the first used commercially available SLA1 printer. You can download the source also. If you want the video of this printer, then this is the site name, http www.3dsystem.com. And this is the first prototype, or this is the first printed part by 3D printing technology. Source is again same. You can, if you want, you can see this YouTube video. The address given this below. Now we'll discuss about the technology involved in 3D printing. Technology or process. Classified according to state of the raw material, which is utilized in this process. The two type technology, but here bifurcation of 3D printing is 4 types. First one we discussed already, fused deposition modeling, FDM. This classification depends upon raw material. In FDM, the raw material is polymer filament. Next one is stereolithography, SL, and raw material are photosensitive liquid resin. In SLS, raw material used are powder, including polymer, ceramic matter also. Other one, nowadays, others, some material also used. Before 4 or 5 days, I heard a news, the paper also used for 3D printing, and laminated object manufacturing, LOM, raw materials are paper. First one was the FDM. Basic principle, or first you can see this slide. a photo picture of 3D printer which used the FDM technology, Fused Deposition Modeling. Basic principle, same here. A filament of polymer is extracted from a nozzle where it is heated above its melting point and deposited on the table surface. When this layer solidified, the nozzle is coordinate according to the part of geometry at the that level. The polymer is again exhausted, and when it contents the previous surface, it solidified to from second layer. The procedure repeated until the part is finished. This is like a iterative method in mathematics. The material used, typically FDM requires two types of material: support material and build material. Build material, what is build material, which constitutes the desired 3D form geometry, and support material, which is required for overhangs the support structure, are automatically generated by the software program support the FDM 3D printer. Now, we'll discuss about stereolithography. Formlab 2 SL printer, you can see in this slide, Formlab 2 SL printer. The basic principle, the platform is initially positioned near the surface of photosensitive liquid polymer. A directed laser beam solidified the polymer. When initial layer is completed, the platform is lowered and second layer is formed. The procedure is repeated until the part is finished. Now, the application of this type technology, first one is automotive industry. 3D printer in the automotive industry use both prototype and actual parts. Many Formula One racing teams have been using 3D printing for prototyping, testing, and ultimately creating custom car parts that are used in competitive races. Next one is medical industry. You can see the artificial leg and artificial skull used by 3D printer, this technology. With 3D printing, surgeons can produce patient-specific 3D printed models, body parts, or organs. They can use this model to plan and practice surgeries, potentially saving lives. In dental industry, the same replica of tooth or teeth you can create by this technology. And aircraft, GE Aviation and Safran have developed a method to 3D print fuel nozzle for jet engines. The technology allows engineers to replace complex assemblies with a single part that is lighter than previous design. Save weight and boost a jet engine fuel efficiency up to 15%. Okay. In education, yeah, in education, three-dimensional figures in geometry, in three-dimensional coordinate geometry, we can visualize many type of prototype or many type of models by this technology. Some more application fields are entertainment, art, design, architecture. Even architecture at this time, but before 2 months ago, they also by this technology we all can. I read some article. Okay, this one we will discuss in last slide. The pro and cons, advantage and disadvantages. You can see the advantage. First one we will discuss advantages, the complexity and freedom of design. 3D printing lets create complex shapes and parts, many of which cannot be produced by conventional manufacturing methods. Complex geometry can be created easily and it allows a large amount of design freedom. By using 3D printing, complex model can be produced as a single pieces on a spot. Therefore, there is no need to produce a smaller part and assemble them. This is the figure of 3D printed lamp showcase. Customization and personalization. Yes, for easy customization, each and every item can be customized without additional manufacturing costs. If there is a need to change a design, a particular item, the digital design has to be changed only with no expensive manufacturing process or additional toolkit. Even no change in production line, mechanical production line. Only digital design change, then we can create customized items. No need for tools. One of the advantage of this technology to traditional manufacturing is that in this technology process generally doesn't require any special new tooling to produce model or its parts. No additional cost or lead time are required. Lead time to required between making an object complex or simple. Speed and cost saving. Speed means V equal to U plus 80 type, not a speed. The speed is a time limitation, actually time. This speed we will discuss about speed in time domain. The 3D printer is the speed of production. 3D printing is the speed production comprising the traditional manufacturing method. Complex models can be printed in relatively short time. Lowering cost is also achieved by saving time. For example, object of their part could be quicker and they are needed. Therefore, the cost of inventory storage and labor time could be reduced. Less waste, sustainable, environmental friendly. Additive process, an object is created from the raw material layer by layer. Additive manufacturing method generally only use the amount of material needed to create that particular object. Means no waste of material. Most processes use material that can be recycled or can be reused for more than one build, resulting in additive manufacturing process. Very little waste. Now we will discuss about the disadvantages. The disadvantage, first disadvantage, maybe in future this is not remain disadvantage, but at this time the higher cost for large production run. The price of printer and raw material are still expensive, but in near future this will uh, tend to minimize. Less material choices, color, finishes. There is still some limitation compared to conventional product material, color and finishing. Limited strength and endurance. Not all printer technology can ensure strength of product object, and the strength is not uniform due to the layer by layer fabrication process. Accuracy of printing object. If there are need a printed pieces part of finer detail, it is still difficult to ensure the high precision capabilities. high accuracy or certain manufacturing process. Majority of 3D printers are limited by scale and size. Now, as we discussed earlier, this is the recent development of this technology. You can see in this picture, this is the 1 BHK flat created by this technology, 3D printing technology. And the advantage of this in flood area like Bihar, Eastern UP, we will achieve the target of governments. Even this you can see in this picture, this is the whole structure created by this 3D printer. First manufacturing solution is startup founded by the alumni of IIT Chennai. This 3D printed house overcome the pitfalls of conventional construction. The house was inaugurated by Finance Minister Nirmala Sitharaman. Thank you.